From the left side, this would be what? Negative infinity. And what is it from the right side? So again, if I ask you what's the limit of f of x as x approaches the 1, this will be what? dne. Does not exist because the two values don't match each other. They have to be the same value. So we're talking about infinite limits, the limit approaching infinity. Now, if I take this function, I'll give you another picture. What's the limit of f of x, bless you, as x approaches 0 from the left side? Infinity. What is it from the right side? Infinity. So if I say what's the limit as x approaches 0 now? That's infinity. That's an infinite limit. The limit is going toward infinity. If you have the picture, it's not really that bad. If you don't have the picture, it's a different story. And I'm just looking to see. Okay, we'll be doing some problems where the picture is not given to you, just the expression. But first, they want us to talk about vertical asymptote versus. Do we talk about horizontal asymptote too? Nope. Vertical asymptotes. And we'll come back and talk about that. Sometimes you have more than one. The way the book defined vertical asymptote, it'll say if the function f of x approaches infinity or negative infinity, I'll put parentheses, or negative infinity, as x approaches c, as you approach a value from the right or the left, then the line x equals to c is a vertical asymptote. Of the graph of f. Again, I have this picture. Let's say my function looks like this. Notice this is x equals to what? Negative 2. It says if the function approaches infinity, so notice you're approaching infinity as you approach this number, or negative infinity as you're approaching that number. from the right or the left, then the line, which is this case x equals negative 2, that's this line going up and down, is a vertical asymptote of the graph of f. Vertical asymptote means you'll never touch it, you'll never cross it. You'll come approaching that number, gets closer and closer and closer to it. The same thing down here, if you're stretching it, that's what's going to happen. So x equals minus 2 is known as a vertical asymptote. Again, everything is not bad when you have a picture. If you don't have a picture, we got a problem. If I have this picture, go, that's easy, just look at the picture. Let's see what we have. I got this picture. How many vertical asymptotes do you have here? You got 2 of them. This is one of them. X equals what? Negative 2. And this another one, x equals to 2. Because as you approach this x value, bless you, as you approach this value, what's happening to the y value? It's approaching either plus infinity or negative infinity. The same thing right here. As you approach x equals to 2, your function is either going to negative infinity or plus infinity. So in this case, I have 2 vertical asymptotes. One at x equals negative 2, the other one as x equals to 2. But if I don't have the picture with me, how would I find them? Just like, what's the limit as x approaches a value? Is it infinity or negative infinity? If I don't have the picture, how would I find that answer? So let's look at some of these. Let's stay with the vertical asymptote, try to finish it, get it out of the way. Then I'll come back to this, finding the limit without having the picture. Find the vertical asymptotes. How do we find where the vertical asymptote without graphing it? Go ahead, Ramon. Where the function is undefined. Yep, be more specific. It's correct. So how do you find out where the function is undefined? Find out what value makes the bottom 0. Exactly. So you take the bottom, set it equal to 0, divide both sides by 2. What's x equal to? Negative 1. That's your vertical asymptote. I bet you if I graph that, I will have a line that goes up and down at x equals minus 1. Where's my calculator? Right here. One divided by parentheses 2 times parentheses x plus 1. If you didn't know by now, I'm a fan of parentheses here. And I go graph it. You should see at minus 1, there's a line that goes straight up and down. Can you see it on the screen? That's your vertical asymptote. In some cases, you have more than one, like this one. Find the vertical asymptotes. I will give you a hint. I said asymptotes with an S. Plural. That means more than one. Again, what do we do? Ramon said take the bottom, set it equal to 0. Find out what makes the bottom 0. You can either factor this or move the -1 to the right side. And we have a method called the square root method. If you have something square equals a number, then that something, which is in this case x, equals plus or minus the square root of 1. So I have two vertical asymptotes, one at -1, one at x equals to +1. If you don't like what I did here, then factor it. It's x minus 1 times x plus 1, the difference of two squares. You'll notice there are two numbers to that. Where's my calculator? Let's see if we have two answers. Here we go, parentheses. X squared plus 1, close that, divided by parentheses x squared minus 1. Graph. Look at that. We have one, just then put the line there in case you can't see it. We have 1 at x equals to -1, and we have 1 at x equals to 1. Now let's try another one. Almost done. F of x equals x squared plus 2x minus 8 over x squared minus 4. My vertical asymptotes where? -3. So x squared equals to what? 4. X equals plus or minus the square root of 4. I got two of them. Again, if you graph that, you're not going to see a line at -2 and +2. The reason, because your calculator will actually simplify that. They'll go, wait a minute, let's simplify it. When you factor that, that's x plus 4 times what? X minus 2. The bottom is what? X plus 2 times x minus 2. And what do you notice about the top and the bottom? Same, these two cancel them out. So what the calculator is going to graph for you is this function. And this will have only one vertical asymptote. Where? At x equals -2. You're only going to see that, not this one. That's at x equals to 2, that's a removable discontinuity. Well, watch the graph on my calculator. Y equals, clear that. I'm going to type that function. X squared plus 2x minus 8 divided by parentheses x squared minus 4. Graph it. Let me zoom in even more. Window, oh, I didn't mean to do that. Window, -10 to 10. -10 to 10, so you'll see a better picture. And graph. No, it's only one of them. Because the calculator is going to graph the simplified version of that problem. But the original problem has two vertical asymptotes, one at -2, one at +2. So in some of the questions you're going to see for the homework, determine whether the function has a vertical asymptote or a removable discontinuity. Again, x equals to 2, that's a removable discontinuity. Notice this function is not continuous at -2 and +2. This one at -2, so we have a removable discontinuity at x equals to 2. Now, let's try infinite limit or finding the limits. If I gave you this problem, find the limit as x approaches 3 from the plus side without graphing it. Tell me, is that a positive infinity or a negative infinity? Let's look at this. Let me write that function. X squared divided by parentheses x squared minus 9. And let me approach it from the right side. Table. Oh, I didn't mean to graph it. I don't want to graph it. Now you saw the picture. 3 from the right side. So what are we getting 3 from the right side? Like 3.1? 3.001, 3.00001, 3.0000001. And where do you notice that number is going? Can you see it? Where is it going toward? It's going toward infinity. Positive infinity. So this function approaches positive infinity from the right side. Now, when I look at these problems, I say, well, how am I going to do this? It's really nothing, just plug in numbers. You don't have to use that many numbers. You can take 2, 3 numbers approaching the 3. I started with 3.1, 3.001. If you take like 3.001, 3.0001, you'll see the answer quickly. If you do it from the left side, it's going to be the same thing. Again, from the left side, I'm going to use 2.999. 3 nines. Negative 1,499. 2.9999. Is that the same number? Negative 149999. Can you see it? Where's that number going toward? Negative infinity. So you can see from the right side is going toward plus infinity. From the left side is going where? Toward negative infinity. If we ask you for the limit as x approaches 3, then this one does not exist. Let's try another one without a graph in it. We said the table is the last resort, but in some of these cases you really can't simplify the problem. So you're stuck with it. We want it from the left side, the minus side only. And again, even if you don't have a fancy calculator, just plug in a number close to 0 from the left side, like negative 0.001 and negative 0.0001. Try these numbers, and you will just, even if I don't have this, if I pick a cheap calculator, something for like $4, do I have one here? I used to have them. Not with me. Well, you know what? Oh, my phone, then I won't see it. Here we go. I'll get out of this fancy stuff and I just do it like basic calculator. I go 1 plus 1 divided by negative 0.001. Negative 999. Let's get closer. 1 plus 1 divided by negative 0.00001. And what do you see that number is going toward? Negative infinity. Color points and you have the answer. I could make an ugly problem like this one. The limit of e to the negative 0.5x sine of x as x approaches 0 from the right side. Again, color of numbers. Use from the right side, use 0.001 and 0.0001. E to the power, where's my e here? Negative 0.5 times 0.001, close that, that's e to the power, times the sine, and I really forgot to put me in the radian mode. Where's mode? Go to, let's see what the problem here. E to the, oh, that's the wrong minus. Minus 0.5 times point times sine. Notice what the number is. Can you see it? Even with degree. It's going to get worse when I switch it to radian. Where's radian? Degree, oh, mode. Where's mode? Where'd you go? Mode. Second. Oh, yeah. Let's go to radian. I'll forget tomorrow to switch it back. Look at that number. What do you got? I got 0.000.0009999, right? Is that what you got? And let's try the next number. E to the power of negative 0.5 times 0.00001, I even get closer, times the sine of 0.00001. And what do you have? 0.00001234599. Where do you see that number is going toward? Where is it going toward? 0. So that number approaching 0 actually.
put in the 0, you get 0.
If you graph this function, actually, let's see what the graph is. If I think what it is, it's actually a neat picture. Negative 0.5x sine of x. And that's the graph. Let me zoom in on the window. Negative 5 is too far here. To 5. Negative 5 to 5. Look at the picture. Start to level up and down, up and down, up and down. So as you're approaching the 0, as x approaches the 0, can you see where the y value is going toward? You can see it close to 0. So the graph of that looks like this, where I'm enlarging the picture a little bit there. It looks like this. So as you approach the 0 from the right side, what's the y value? From the right and the left is 0. But you can find the limit by taking just color points without having to graph it. I'm just showing you the graph to show you the answer does actually match what we're talking about. And that's the end of chapter 2.